We've seen an example in MATLAB where if I do pi to the fourth times pi to the negative fourth equals 1. So secretly we know that the left side and the right side are equal, so we're expecting to get true for the output. But we don't get true, we get false. So this is an example where two numbers are equal, but MATLAB tells us that they're not equal because of some limits of numerical precision. There are also examples in the other direction. For example, what if I do 2 to the 60th plus 3, and I ask, does that equal 2 to the 60th? So here MATLAB tells me, true, these two numbers are equal. Even though we can tell that they're not equal, they differ by 3. And one of the main ways to look more precisely at these kind of results is with some built-in command in MATLAB called EPS. So for example, if I do EPS of 1, what do I get? I get the number 2.22 times 10 to the negative 16. That's what this E minus 16 stands for. It's scientific notation. So what's that telling me? It's telling me what's the next number that MATLAB knows about that's bigger than 1. So some number that's between 1 and 1 plus this number, this small number, think of it as 1 plus epsilon. It's either going to be rounded down to 1 or rounded up to 1 plus this tiny number. So how can this EPS symbol, how can that help me understand this result up here? Well, let's look at EPS of 2 to the 60. So what's that telling me? It's telling me that every number between 2 to the 60th and 2 to the 60th plus 256 is going to be rounded either down to 2 to the 60 or up to 2 to the 60 plus 256. So in particular, 2 to the 60 plus 3, that gets rounded down to 2 to the 60. If I do 2 to the 60 plus 100, and I ask, does that equal 2 to the 60? MATLAB tells me true, they're equal. If I do 2 to the 60 plus 200, does that equal 2 to the 60? Here I get false, they're not equal, because this one, it gets rounded up to 2 to the 60th plus 256. Okay, so if we want to look at it, here I get that these two numbers are equal. One other thing I want you to know about in MATLAB, let's look at this number. Let's look at a 1 followed by 350 zeros. And let's try to print it to the screen. And what do I get? I get infinity. So MATLAB, it doesn't have a way of working with numbers bigger than 10 to the 350. At least on my computer. On your computer, there might be slightly different standards. This, in general, it uses floating point arithmetic. So for bigger numbers, it has less precision. For smaller numbers, like, where was it? Like here, like 1. For smaller numbers, it has higher precision. And that makes sense. If you're working with some data that's on the order of 50 digits long, you're not going to expect it to be accurate to the same number of decimal digits of precision as a small number like 1. If you want to know specifically what's the biggest number that MATLAB knows about, you can type in real max. So this tells me that approximately 1.79 times 10 to the 308, that's the biggest number that MATLAB is able to work with. We're not going to work too carefully with numerical precision in MATLAB, but to me it's important that you know what the limits are of numerical precision in MATLAB. For example, a true-false question I might ask you in MATLAB would be, true or false if x is a number defined in MATLAB and we type x plus 0.1 equals x, the answer will always be false. So for example, I could have something like x equals 10 to the 50th. Okay, and then I could ask x plus 0.1 equals x. And you should imagine the true-false question that I ask you is true-false. The answer of this is always going to be false. They're not equal. But here's an example where the answer is true. They are equal. So that's about the limit that I want you to know of numerical precision in MATLAB. Also, I want you to know that in general, writing equals equals is dangerous to do in MATLAB unless you're working with something like integers or maybe single decimal digit approximations like 5.3. Okay, if you're working with something like square root of 2, that irrational number, or pi, that transcendental number, then using equals equals is probably very dangerous. And better if you want to know, does x equal y? So let me just do an example. 10 to the 50th plus 0.001. Okay, instead of asking does x equal y, it would be better to ask is x minus y small? Okay, so this is almost right. I could ask is it less than 0.1? But that's not really that good, because if x minus y is negative 50, then yes, it's going to be less than 0.1. So really you want absolute value signs in front of it. So in general, instead of writing x equals y, it's much safer to write absolute value of x minus y is small, less than some bound that we choose. So here we get that this is true.